Okay, we're going to have a look at integrating the absolute value of cosx between 0 and pi. So I guess the first thing to note here with our absolute value, we need to understand that the function of which the absolute value is taken, we're looking for values where it's positive and negative. So for any positive, wherever cosx is positive, we'll think of this expression as positive cosx. Wherever cosx is negative, because the absolute value means that it must be a positive value, wherever cosx is negative, we'll be multiplying this function by -1. So the first thing we need to know between these boundaries of 0 and pi, where is cosx positive and where is it negative? So we can do that by having a look at our unit circle over here. We know for an angle on the unit circle, the cos of the angle is this horizontal component here. We can see that's going to be positive for any angles between 0 and pi on 2. And then as we move past pi on 2, between pi on 2 and pi, we get negative values of cosx here because the horizontal component is negative. So what we can do with this integral is break it up into two separate integrals and integrate it between 0 and pi on 2 to begin with. And we know the value of cosx will be positive in this region here. So the absolute value of cosx will just be equal to cosx. And then we can add the integral from pi on 2 to pi, which is sort of this region through here, where the absolute value of cosx will be the same as the negative of cosx dx. Reason being is that, within this range here, cosx will generate negative values. So to get the absolute value, we need to multiply cosx by that negative value. We can then just go and integrate these two, or evaluate these two integrals separately, which is pretty easy. So we'll get sine x between 0 and pi on 2 plus negative sine x between pi on 2 and pi. So this will integrate out to sine of pi on 2, take sine of 0. Don't really need the sine of 0 here, because we know that it will just be 0. And then we'll get plus negative sine of pi, take away negative sine of pi on 2. So that goes to 0. Sine pi is 0 as well. And we're left with sine pi on 2, which we know is 1. Then we've got the negative of negative sine pi on 2, so that'll be -1. Negative of that is +1. 1 plus 1, and we get our answer there of 2. Okay, we can also think about this problem graphically if we wanted to as well. If we were looking at the graph of y is equal to cosx, we'd have our cos graph looking something like this, going through a period, one complete cycle in 2 pi. And we can see with a particular graph here, that would be pi at that point there. And for these values here where the function goes below 0, the absolute value of the function, so if we were graphing y is equal to the absolute value of cosx, this part of the graph here would just sort of reflect about the x-axis. In other words, we're just multiplying the function by -1. So what we can see, if we were integrating between 0 and pi, as in this question, we can actually see that integral of between 0 and pi of the absolute value of cosx dx would in fact be equal to the integral from 0 to pi on 2, just times by 2. Just from symmetry we can see the integral of this part of the absolute value function is going to be the same as from 0 to pi on 2. So we could just call it 2 times pi on 2 cosx dx as well to get to our answer. And of course that'll be 2 of sine x, our boundaries of 0 and pi on 2, which will be 2 times sine pi on 2, giving us our answer of 2 times 1 equals 2. So I guess absolute value, you just have to be a little bit careful with it and just consider the parts of the function where it's negative. I guess it is the key to these types of questions.